In this lesson for optics, we are going to learn about Snell's law and how to apply it. Okay, these are learners' outcome. Okay, some prior knowledge. You need to understand the concept of refractions and how light ray will bend when it changes from different mediums, and to understand what is refractive index of a medium. Okay, refraction of light. For a light ray that's going from faster to slower, it means that it's going from a lower refractive index to a higher refractive index. So light ray will bend towards the normal. So this is one example. Okay. And it also means that the angle of refraction is less than the angle of incidence. So in this case, the angle of refraction, the angle of incidence is about 30. You find that because the light ray bends towards the normal, the angle of refraction is actually less than the angle of incidence. So this is roughly about 20 or about 18 degrees. So from a low to high refractive index, when the angle of incidence increases, the angle of refraction also increases. So in this case, when the angle is increased from 30 to 60, you find that the angle of incidence was increased to 18 to roughly about 34. But however, the angle of refraction will always still remain smaller than the angle of incidence. So this angle of refraction will be smaller than the angle of incidence. Now, if its light ray is coming from high to low refractive index, the light ray will bend away from the normal. So this will be the case where you have high refractive index and then it goes towards the low refractive index. It actually bends away from the normal. This time down, you notice that the angle of refraction, this time down the angle of refraction would be more than the angle of incidence. So in this case, angle of incidence is roughly about 20, the angle of refraction is about 30. Similarly, when the angle of incidence increases, the angle of refraction will also increase to, but of course, it only increases to a maximum of 90 degrees. So this is what happens when your angle of incidence increases to 40 degrees. You find that the angle of refraction, in this case, is increased to roughly about 70 degrees. Do take note that when we talk about angle of incidence or angle of refraction, we always start from the normal as 0. Okay, and you measure the angle like that. Okay, from 0, you measure the angle in this manner. And angle of refraction will always be greater than the angle of incidence. Okay, but sometimes students have challenges identifying how light ray will refract out of the material, especially if it's not their usual diagrams. So if you look at this particular light ray that's going into a high refractive index material, okay, you find that you would sometimes students may not be very sure how do you refract. Okay, you just only need to follow the steps. First, you always draw the normal line where the light ray strikes the surface. So this is a normal line. Second, if you want to know where will the light ray go, just label the quadrant 1 to 4. Okay, you can label it, for example, 1, 2, 3, 4. Okay, so you find that in this case, this is in terms of clockwise. And the light ray, in terms of refraction, where will it go? It will actually always go to the opposite quadrant. So in this case, you find that if it's 4, you will go towards 2. Okay, but if it's 1 or 3, you will go to the other one. Okay, so 1 will go to 3, or 3 will go to 1, 4 will go to 2, or 2 will go to 4. So the following series of diagram actually shows you this pattern. Okay, again, if you label this 1, 2, 3, 4, this is 1, 2, 3, 4. So you find that 1 is to 3, this is 2 is to 4. Okay, and this is from 4 is to 2. And this is 3 is to 1. Okay, let's have a bit of practice. So this is not a very conventional straight block. And how we sketch the refraction light ray? Okay, if you have like this. Okay, even if it's not a rectangle, you just only need to follow strictly the steps. Okay, first draw the normal line, and again label 1, 2, 3, 4. Up to you. Okay, you can do 1, 2, 3, 4. But the idea is that light ray will actually refract towards the opposite quadrant. So as it's going into a high refractive index, so it will bend towards the normal. So you can roughly give a sketch. Okay, bend towards normal means that the angle incidence is greater than the angle of refraction, or this is smaller. So the light ray will travel straight like this. And if it encounter another surface again, where would the light ray go? Will it go out in this manner, or will it go in this manner? Okay, you just only need to follow strictly to the rules. Okay, again, draw a normal line that where the light ray strikes the surface. Okay, so again, label this as quadrant 1, 2, 3, 4. So with this, it's very clear that the light ray will actually come not at 2, but maybe out at 3. Okay, but since it's going from a high refractive to low, it will bend away from the normal. So it should get angle incidence is this angle, so it should be more than this. So you can just sketch something like that. So this angle of refraction off is smaller than the angle incidence, and this will be generally the light ray. Okay, but take notice that this is just a sketch. Okay. So how do we actually precisely describe what is the angle incidence versus angle of refraction, and what is the exact angle? Okay, and this is actually described by the Snell's law, because Snell's law describes the relationship between if you know the refractive index of the two different mediums, and if you know the angle incidence, you also know the angle of refraction. Okay, some textbook put Snell's law as n equals to sine I divided by sine R, where n is the refractive index of a particular medium, I is the angle incidence, and R is the angle of refraction. But however, this is not a comprehensive formula. So I'll introduce you to another formula. Okay, a more comprehensive one is actually something like this: n1 sine I equals n2 sine R. N1 is the refractive index of medium 1, which contains the incident ray. N2 is the refractive index of medium 2, which contains the refracted ray. Okay, it's very important for you to associate medium 1 with incident, medium 1 with incidence, and medium 2 with refracted. Okay, so I is the angle incidence, and of course R is the angle refraction. You can actually rewrite this into this particular form, where you just do a cross multiplication. Okay, where you can shift the n1 down. Okay, and then you can shift the sine I R down to sine I, so you can have this particular format. So it's up to you whether you want to remember this or this format. Okay, a simple application: a light ray goes from air into glass, and given that the angle incidence is 45, calculate the angle of refraction in the glass. So this is the particle format. So this is 45, and this one is what is that? Refraction. So always first identify the which one is medium 1 and medium 2. Okay, again, remember we have told you that incident ray is associated with medium 1, and refracted ray is associated with medium 2. And once you have that, then it is actually quite easy. Okay, what you need to do is to substitute in the value. Okay, so medium 1 is air, so n1 is 1. Medium 2 is glass, so it's 1.5. And then I is 45 degrees. So we just only need to substitute in the values. Okay, and then of course do some again cross multiplication, and you just calculate what is angle R, which is 28.1. Okay, take note that again this is consistent with the angle of refraction smaller than the angle of incidence. Okay, why is it that n equals sine I over sine R is not comprehensive? That is because this particular formula can only be applied to a situation where light ray enters from air into another medium. So under this Snell's law for this situation, the following applies. Okay, you find that this n2 equals to n1 equals sine I over sine R is exactly because n1 is being air. That means that this is 1, so you find that you are simplified to a formula n equals to sine I over sine R. So only the previous situation, this particular formula applies. You find that if you have another situation that if the light ray comes from a medium and enters the air, you cannot use this particular formula. Okay, so something like this. So if this is medium 1 and this is medium 2, you find that you cannot use this particular formula to try to solve angle I or R. In fact, you get it wrong. Okay, so coming to this situation where the medium 1 is glass and medium 2 is air, so particular angle of incidence, and then you try to find what is the angle of refraction. Okay, so again, you just apply the formula, and let's say in this case the angle of incidence is 35 degrees. So, but notice that this time around N1 is actually 1.5 because the incident ray comes from glass. N2 is actually 1. So therefore, if you substitute this in, this is what's going to happen. Okay, and angle of incidence 35 degrees. Okay, and angle of refraction will be about 60 degrees. Okay, notice that for this case, angle of refraction is greater than the angle of incidence. Okay, and you can even apply even if none of the medium is air. Okay, so you can apply that particular formula. So if let's say the angle over here is 60 degrees, and this time around they tell you that this is roughly about 32 degrees. Okay, and the angle, this is water, so this has a refractive index of 1.33, and they want to find what is the N for this particular medium. You can do that. So again, you just only need to apply and gather all the formula values. Okay, so again, medium 1 is actually water, 1.33, medium 2 is unknown, okay, and then I equals to 60 and R is equals to 32. So you just only need to substitute in, and you find that you obtain the value for. So general steps, just determine, first step is to determine which medium is known as the medium 1 or 2, and always remember medium 1 contains the incident ray, medium 2 contains the refractive ray. To determine if you have the angle of incidence and refraction, and draw the normal line if it's missing from the diagram, because you always measure the angle from the normal line to the angle of incidence, to the incident ray, or to the refracted ray. And determine if whether you have refractive index of the medium 1 or 2, and substitute into the Snell's law and the values that you have to find the specific error. Okay, so that's how you apply Snell's law.